Lesson 5 is about operations. So we have these objectives. After completing this lesson, you should be able to discover, rediscover, add and remove the Oracle VM servers from your environment. Well, this operation is basically about you, as you know, the first time you prepare the environment with the Oracle VM Manager, you need to discover the Oracle VM servers. At the beginning they are unassigned, and after that you start to create the subpools, classes subpools, and you need to include these servers, the Oracle VM servers, into this cluster or non-classes subpools. Rediscovering is an operation that need to be performed, for example, when you are adding plugins for storage elements, or for example you modify any hardware structure or devices that you include in the VM servers. And adding and removing is the way that, for example, you want to include at a later time additional VM servers, and removing means that they're no longer available, or you're no longer going to be part of a subpool, any of the Oracle existing VM servers that you have in your infrastructure. That topic is to describe the subpool operations. It's like, for example, to perform some tasks such as working with the VM servers that you need to include in these subpools, and also the operations related to, for example, working with classes subpools, the different components that are needed for the classes subpool, much like for the subpool file system or the class that have been network. There are discover all repositories and move repositories between subpools and reclaim repositories. So we also perform some operation related to the repositories. Rediscover repositories when you, for example, you have additional ISO images, or for example, templates or assemblies that you upload manually, not using the Oracle VM user interface or the CLI. Moving repositories between subpools is the way that you want to move the contents of these repositories to be available from one subpool to another. This is typically when you're working with testing subpools and you want to move the repositories to the production subpools. And reclaim repositories are repositories that, for example, exist in other environments and you want to include in your existing environments. And notify your Oracle VM Manager about changes to the storage layer in your Oracle VM environment, such as, for example, adding additional LUNs or modify existing LUNs in these storage components. Well, the lesson overview, we have multiple sections. In the first section of this lesson, you learn how to manage the Oracle VM server resources in your Oracle VM environment, whether the servers belong to a subpool or not. The next section, you learn how to manage your repositories, and the last topic describes how to refresh the storage layer in your environment. About discovering the Oracle VM servers. After you perform the installation, remember each Oracle VM server has an Oracle VM agent, the OVS agent. It's a process that is running, and it listens for discovery events for the Oracle VM Manager. During the installation of the Oracle VM server, you need to provide two passwords, password for the root, the super administrator of the Oracle VM server, and the password for the OVS agent. These passwords need to be retained to be used later at time. For example, when you discover with the Oracle VM Manager this Oracle VM service. During the discovery process, the Oracle VM Manager contacts the Oracle VM server by using the IP address or the host name specified in the discovery request. You need to populate this information in the system, and in addition to this, you need to provide the Oracle VM agent password. Well, the Oracle VM Manager also specifies the password, which must match the password that you assigned to the Oracle VM server during the installation. The question is that you can use different passwords, different Oracle VM agent password for different OVM servers. So if you have the same password, you could discover the servers at the same time in the same step. Or, for example, if they have different passwords, you need to discover in different steps, providing the different passwords during the discovery process. The Oracle VM Manager performs a series of discovery operations on the Oracle VM server. About these steps, the discovery steps, the Oracle VM Manager performs the following types of discovery operations in the Oracle VM server during the discovery process. Well, you have a matching with the Oracle VM server software. This matching has this operating system, the OVS agent with a specific password, and also you have hardware. So typically you have network interfaces, you have iSCSI or fiber channel connectors to storage devices. So it performs multiple steps. The first one is a basic step in which it gets the Oracle VM server unique universal identifier, and it contact with the OVS agent, and it try to get information from the database. So you have a local database per Oracle VM server that is managed and maintained by the OVS agent. This database is located in the etc OVS agent DB directory. Well, in addition to this, perform, for example, extract the information from this database about the processor architecture, the processor model, and additional information about the devices that you have. About hardware, it detects, for example, the information for the architecture, for example, which kind of virtual machines would you support. For example, is about logical domains or Xen-based Oracle VM server, if it supports para-virtualized, hardware virtualized, or PV-HVM virtual machines. And in addition to this, the compatibility processor capability for this server. About networking, it detects any network interface, bonded interfaces that you created, and virtual LANs that has been set up. About plugins, you have the storage connect initiative, so you have the option to install multiple storage plugins to be able to work or to extend the functionality when you work with the storage devices. In this way, for example, you provide thin cloning, provisioning, authentication, and so on. So you get benefit of these plugins when you work with provisioning operations for the storage. Also the attached LUNs, so it tried to get the LANs, for example, for iSCSI, fiber channel LANs. Also it tried to detect if you have, in this case, local LANs, for example, to work with local repositories. Also about the server database, it gets information from this etc OVS agent DB file, all the information that it contains. For example, it maybe already be part of the Oracle VM installation, a previous installation, and you want to rediscover again. It tried to get information about, try to compare if there are some changes or not in the hardware. Also file system mounts in the etc fstab file, it contains the different mount points, so it helps to detect, for example, if there are additional NFS shares that has been mounted or additional file system that has been created. And the cluster information is to know if it pertains to an existing cluster server pool, and to know, for example, where is the cluster information and the configuration for this cluster. If the Oracle VM server belongs to another Oracle VM manager, only a partial discovery is performed. Well, it gets located in the unassigned Oracle VM servers, because if it belongs to another, the manager is not able to include or to manage or the VM server to be part of a server pool, of an existing server pool. Well, about rediscovering the Oracle VM servers, you need to rediscover this, for example, to update the configuration information in the Oracle VM Manager database. You know that the manager has a MySQL Enterprise repository in which it catalogs all the information. So the rediscovery means that you need to update this information. When you restart the Oracle VM Manager, it performs only a basic rediscovery. If you want to perform a full rediscovery, you need to trigger this, and you need to use the server rediscovery function from the Oracle VM Manager user interface. If, for example, the certificate-based authentication between the manager and the Oracle VM server is no longer valid, we need to use the server discovery action. Rediscovery action doesn't work. So you must specify the Oracle OVS agent password as part of this discovery, this full discovery process. Well, now, operations on the Oracle VM servers. After you discover the Oracle VM server, it should appear as an unassigned server pool. Sorry, an assigned server in any of the server pools that you exist. So you can configure file-based NFS or block-based iSCSI fiber channel storage. You could create additional networks and add ports or bonds from this Oracle VM server to the network configuration. Also, you could present the Oracle VM server to NFS type repositories. You could rediscover the Oracle VM server. If, for example, explained you before in the other slides, you perform any kind of change, right? Also, you can add the Oracle VM server to a SEBA pool, to an existing SEBA pool. You could release the ownership for the Oracle VM server. Releasing the ownership means that you detach or you disconnect the VM server for this Oracle VM manager configuration. Show is the typical action when you want to move this server to another Oracle VM manager infrastructure. And also you have the option to delete the Oracle VM server. Well, some of these actions obviously take effect or they affect, for example, to the metadata information that is stored in, for example, the MySQL, the Oracle MySQL Enterprise database, the Oracle VM manager repository, and also in addition to this, the local database that you have in the etc OVS agent DB directory in the Oracle VM server. Well, deleting the Oracle VM servers, you can delete an unassigned Oracle VM server at any time. So you need to, first of all, guarantee that you, for example, release the ownership to be able to, for example, to delete. In addition to this, if the Oracle VM server is part of a SEBA pool, you need, first of all, to migrate all the running virtual machines from the SEBA to another. You need to unpresent the repositories for this server. This is optional, but usually it's complete this step at the time you try to delete the VM server, but if you do it before, okay, you will help to the delete operation. And after that, you need to remove the server from the SEBA pool. You see that the server cannot be member of a SEBA pool to be able to be deleted. And now you can delete the server from your Oracle VM environment using the Oracle VM Manager user interface or the command line interface. Well, deleting an Oracle VM server that is no longer accessible. What's happening if the VM server has a hardware failure that you're unable to solve, is not able to be started again and be visible or available from the Oracle VM Manager interface. So optionally, you have the option to migrate the virtual machines on the VM server to the SEBA pool level or to another VM server in the SEBA pool if it is possible. And to delete the Oracle VM server, what it does is to impresent from the repository operation should fail because the server is not available, and the Oracle VM server is deleted from the SEBA pool. So automatically it updates the database information, removing any entry that may reference to this OVM server in the existing OVM infrastructure. And the Oracle VM server no longer appears in the environment. Well, what's happening, for example, we need to perform a reinstallation of the Oracle VM server. If you reinstall an Oracle VM server that is already part of a SEBA pool, the server reappears in the SEBA pool within an unknown status, and the certificate-based authentication is no longer valid. So at this point, you need to discover the Oracle VM server to reestablish the authentication path. So now the Oracle VM server appears as unassigned. And to complete the recovery, we need to configure the network and the storage for the Oracle VM server. We need to add the Oracle VM server to an existing SEBA pool, and we need to present the repositories to the Oracle VM server. Well, for SEBA pool configuration, for cluster SEBA pool, you specify a cluster timeout value. By default is 120 seconds. And the SEBA pool file system, remember, which you store the information about the membership of the cluster, and in addition to this is where, for example, the disk herbit is implemented, and optionally a dedicated herbit for the network herbit to maintain the consistency of all the OVM servers in the same cluster SEBA pool. The Oracle VM servers in the same cluster SEBA pool must reside in the same physical location. Well, for SEBA pool operations, you can add Oracle VM servers to a SEBA pool at any time. After, for example, you discover new ones, or you rediscover again, or you reinstall, right? If an Oracle VM server is shut down, the server releases or leaves the OCFS2 cluster. so the server can rejoin the cluster when it comes up again. But usually it shows us this in the display of the server. It shows us the version of the software, the version of the Sun server, the status, but typically it shows us if it's part of the cluster or not. If it's not part of the cluster, it usually appears a read message that the known cluster, right? And this is why we need to wait. We need to leave the OCFS cluster, and when it start again, it will rejoin. If an Oracle VM server fails to write to the Heartbeat device, it indicates a self-fence operation. And during the reboot, the server rejoins to the cluster. So if the Oracle VM server fails the rejoin operation, we need to find out why the Oracle VM server cannot access, for example, the server pool file system. Well, in the next lesson about troubleshooting, you will get additional information about why, for example, a server is not able to join again to the cluster server pool, to join to the cluster, because maybe has some kind of issue with the server pool file system, or have some kind of issue with the networking, Heartbeat connectivity, or something like this. Well, about the next section for Oracle VM repositories, you can present an NFS-based repository, remember, to any Oracle VM server that has access to its NFS share. But you can present an OCFS-based repository created on an external LUN only to Oracle VM servers of the server pool specified when creating the repository. You can create a local repository on an Oracle VM server on any unused local disk of the Oracle VM server, and on the unused portion of the Oracle VM server installation disk if this unused space appears as a physical disk in the local storage volume group for the Oracle VM server. Remember that these local repositories are only being accessible by the Oracle VM server, and is to create the VMs that are able to be running only on that Oracle VM server. They lost powerful functionality, much like load balance capabilities or reliability capabilities. Well, each repository has an ownership. So for all repositories, the owning Oracle VM Manager unique universal identifier is stored in the repository. Well, each repository is shown as you know, as a directory in each server. So you should be able to get access to the directory for the repository through these Oracle VM servers to which is presented the repository. And this directory contains a hidden file, which is the .ovs repo file. So with the cat command, for example, you are able to display the unique universal identifier information. As you see in this example, you get the repo unique universal identifier, which identifies uniquely this repository, and also you get the repo manager unique universal identifier. This is the unique identifier of the manager that manage, that control, that discover, that works with this repository. And also, for example, the alias to let you know, to identify which is this name. Well, the repository with the cluster server pools has different functionality that the NFS-based repositories, because remember, the NFS-based repositories you can present to multiple server pools, but repositories with cluster server pools, okay, they are created on external LANs and always belongs to a single server pool. The repository and the server pool belong to the same cluster, this is mandatory, and each OCFS file system has two entries, the dep device entry and the dep mapper entry. So typically, for example, if you type the mount command, you will see that appears much like the dep mapper entry, but also you should be able to make reference for some maintenance tags or something like this with the other way, which is the device entry. Notice that the server pool file system and the two repositories share, for example, the same cluster ID as shown you before. Well, the way that you get information about the unique identifier for the repository, and for example, if they belongs to a cluster server pool or not, is using the mounted.lcfs2 command with the -d option to display this information. So here we have, in this case, 3, right, and 2 with the both ways to identify the dep device ID and the dep mapper ID. It shows us the stack O2CV means that they are OCFS2 based repositories, and with the cluster you see that all of them has the same cluster unique identifier. So this means that all of them, okay, are presented, are configured for this cluster server pool, and the unique universal identifier is for identifying, okay, each of these both repositories. Well, repositories on local disk, remember you have the option to do so. So it uses this OTFS type file system to create, but remember that these repositories cannot or does not belong to a server pool. So they are accessible only by the Oracle VM server that created, and are used, for example, to store ISO images, resources that are being accessible by only this Oracle VM server, or to run virtual machines on only this Oracle VM server. So in the example about mounted.otfs2-d, also you get additional information about describing. You will see that typically it appears with an empty value for the cluster ID, meaning that it doesn't pertain to a cluster, so it's a repository that is a local repository. Well, for the operations that we are able to perform with the Oracle VM repositories, we have the option to present and unpresent repositories to the Oracle VM servers. Repositories which are based on NFS, or for example in Iascasio forward channel using OTFS2 file system. Presenting and unpresenting means it's exactly the same than mounting and unmounting, okay, these repositories in the Oracle VM servers that are members of the server pool. Also, you have the option to refresh a repository to synchronize its contents with the Oracle VM Manager database. Is when you, for example, want to upload ISO images or templates manually or using an external mechanism and not using the Oracle VM user interface or the CLI functionality. Also, you have the option to create a repository export for OTFS2 type repositories. Remember, this is much like these repositories are mounted on the VM servers, and in the VM servers you create an NFS share that, for example, with a client host you should be able to mount, and in this way to upload ISO images, templates, virtual matching files, or virtual disks for the virtual matchings, right? And after that, to refresh, remember, the repository. You will have the option to delete a repository and its contents. Obviously, you need to be careful with this. And also release the ownership of a repository. This is when, for example, you want to move a repository from one environment to another, from one Oracle VM Manager to another, and reclaim the ownership of a repository. This is, for example, when the environment gets destroyed, you need to recreate again, and you want to include this existing repository that was survived to this disaster, okay, in this new Oracle VM environment that you created from scratch due to the disaster. What about removing a repository? You can do this, for example, deleting the repository or releasing the ownership of the repository. So the repository must be empty before attempting to delete it. So you need to find a way to extract the contents and to remove the contents, and you perform the delete operation from any Oracle VM management interface with at least one Oracle VM server that's still present to the repository. So it need to be present, it need to be mounted to be able to let to the Oracle VM server to delete the repository. And releasing the ownership of the repository in the Oracle Manager user interface, you edit the repository and you select to release the ownership. And if you want to do so with the Oracle VM CLI, you use the release ownership repository command. But reclaiming a repository after rebuilding the Oracle VM, so after you rebuild in the Oracle VM environment with the same Oracle VM Manager universal unique identifier, the rebuild server pools have new cluster IDs. With the OTFS type repositories from the previous environment, they have the cluster ID from their former server pools. So if the ownership was never released, and you can reclaim its repository by updating the cluster ID on the repository by using the OTFS utility. Well, that's the problem when you have a repository that was a member of a cluster server pool and you want to reclaim, okay, it contains different cluster ID unique identifiers. You need to use the OTFS utility to remove these old references and to update with the new ones. Okay, basically that's the most important. Well, you will learn later in the next lesson about troubleshooting, how to do it so. Well, and finally about storage refresh operations, you perform refresh operations to notify the Oracle VM Manager of changes to the physical environment. Well, the situation when you add additional loans, you remove existing loans. When you resize, for example, the existing loans, because you use, for example, storage applications or firmware that helps you to do show because you work with third-party providers or storage vendor providers, or for example with Oracle storage appliances, much like the Oracle FFS storage appliance. So for the refresh operation, you include to rediscover the operation for the Oracle VM server, letting to the Oracle VM server to view these new LANs. So they should be able to be included as a repository, or to be, for example, be able to be used as physical LANs for the existing virtual machines that you have running in these Oracle VM servers of a specific server pool. Also, the file server refresh is to detect, for example, new NFS shares, right? File system refresh is, for example, to detect new, for example, local storage. Also, you have the CERN server refresh to detect new or modification in the LANs, and physical disk refresh is when you take an action on a specific LAN, much like resizing the LAN, you have the option to refresh this. So for the quiz, which of the following refresh operations can you perform in your Oracle VM environment? A, file server refresh, B, repository refresh, C, Oracle VM manager refresh, D, all of the above. The correct answer is A and B, because you cannot perform an Oracle VM manager refresh. You can refresh a file server, you can refresh a repository, you can refresh a physical LAN, you can refresh a file system, but you cannot refresh the Oracle VM manager as it is. So as a summary in this lesson, you should have learned to discover, rediscover, and remove Oracle VM servers from your environment, describe server pool operations, rediscover repositories, or much like move repositories between server pools, and reclaim repositories, and notify your Oracle VM manager about changes to the storage layer in your Oracle VM environment. Practice 5-1, remove one Oracle VM server hard removal. In this practice, you remove one Oracle VM server by shutting it down and reinstalling it. This is a hard removal because you do not go through the Oracle VM manager to remove the server from the server pool. After reinstalling the Oracle VM server, you add it back to the Oracle VM environment. This practice demonstrates how an Oracle VM server can be yanked out of an environment and then returned to the same environment. In the very dynamic environment, it is not unusual to have servers move between environments. For tags, first one, we are going to hold the ovsvr02.example.com from the command line of the server. So from your active CSON to ovsvr02.example.com, we execute the HAL environment. Well, if we have an active CSON, we open a new one. We change to root, provide the password for root in the lab host, and we connect with ovsvr02. Remember, password is Oracle, and we execute the HAL command. If you have no active CSON to the Oracle VM Manager user interface, we start Firefox and use the following URL to access to the Oracle VM Manager user interface. I'm going to open another terminal. I'm going to repeat similar steps than, for example, in previous lessons. Password is Oracle, and we invoke Firefox -no remote &. And we navigate to the http ://localhost 7002 /OVM/console. Okay, we get logged with the admin user, password my Oracle1. In the Oracle VM Manager user interface, we may click in the servers and VMs tab. and view the icons that have appeared next to the OVS SVR 02.example.com Oracle VM server in the Sebep pool 1. So we expand Sebep pools, we expand pool 1. It can take a couple of minutes before the icons change, and the red square icon indicates that SVR 02.example.com is offline. We view here also the pool show us that some of the servers are not available. The red octagon icon with the white X indicates a critical error. Note, if you want to bring down a server gracefully for any reason, always use one of the management interfaces to Oracle VM Manager. In this practice, you simulate the non-graceful removal of the Oracle VM server. Step number 2, we reinstall the Oracle VM server for X86 software in the OVS SVR 02.example.com and reboot the server. Note, in these stacks, you do not reinstall the software on the Oracle VM server. You simply copy a clean installation disk to replace the current system disk. From a terminal window on your desktop, log it as root. Make sure that the OVSVR virtual machine does not appear in the list of running domains. Okay, I'm going to minimize these windows. I'm going to open a new terminal. We get logged as root in the remote lab host, and with the XM list, we check that the OVS VR02 doesn't appear in this list. Next step is to access the OVS running pool OVS VR02 directory and list its contents. Note that in this case you see that we have the system image file and the configuration file. Now we move the current system disk system.image to system.image.all. We copy the save system disk system.image underscore clean install to system image. And we list the contents. So now we should have the system image, that is the existing system image clean install, the whole, which is the old system image that we held, and the clean install underscore 2. Note that you use the system.image underscore clean install underscore 2 file in a practice for a lesson titled Backup and Restore DR Concepts. Next step is to restart the OVSVR02 virtual machine by using the XM create command from the OVS running pool OVSVR02 directory. Note that what happened in the Oracle VM Manager user interface as OVSVR02.example.com reboot. So because we are located in this directory with the XM create, we invoke it in this way. Well, the domain ID assigned to your OVSVR02 virtual machine is different. The OVSVR02 virtual machine takes several minutes to boot. In the Oracle VM Manager user interface, the OVSVR02.example.com server now displays as blue. Well, so we need to wait to lead to this entry, the OVSVR02.example.com, to be in blue. Blue indicates that the Oracle VM server has an unknown status. Next step number 3, if critical events are present for ISCSI_PVM1, we clear these critical events. If the ISCSI_PVM virtual machine was running on the OVSVR02.example.com server before the server was halted, this virtual machine has critical events logged against it. To clear these critical events, you must acknowledge them by performing the following steps. In the list of the virtual machines currently assigned to OVSVR02.example.com, we select the ISCSI_PVM1 right click and select display events. So we select this one, we have a perspective drop down list virtual machines, and we have the ISCSI_PVM1. So we may click right click, and we have the display events. In acknowledge all, you get this message, and we may click in OK in the confirmation window. The severity level changed from critical to informational. So now the event severity changed to informational. We examine the events log against the ovsvr02.example.com and the operations that can be performed for this Oracle VM server. We examine the events for the ovsvr02.example.com by selecting the ovsvr02.example.com in the navigation pane and selecting events. So you put focus on this one, and in perspective we have events. So you will see that the events for the ovsvr02.example.com are displayed. There is an authentication error for ovsvr02.example.com. Because of the error, the OVM manager is unable to communicate with the server. So we examine the operations available for the ovsvr02.example.com by selecting the ovsvr02.example.com in the navigation pane and opening the shortcut menu with a right click. The only operations available are create virtual machine, edit, delete, generate report, find, and help. The generate report operation allows you to generate an XML report on one or more of your servers. In the edit operation, there is no way to specify the Oracle VM agent password, so you don't want to delete the server, therefore do not use the delete operation. Return to the Oracle VM server ovsvr02.example.com to your Oracle VM environment by discovering your server. Look at the information of ovsvr02.example.com from the Oracle VM Manager user interface by using the info perspective. Note that the Oracle VM server is owned by you. The next steps are performed to re-establish the communication with the Oracle VM Manager. Click the Discover Servers icon on the toolbar in the navigation pane. We enter the OVS agent as the Oracle VM agent password and 192.0.2.102 as the IP address to discover ovsvr02.example.com. The 192.0.2.102 IP address is ovsvr02.example.com address on the management network. The Oracle VM agent password was specified during the installation of the Oracle VM server for X86 in the ovsvr02.example.com. So this is OVS agent, the password, and we have 192.0.2.102. Well, the job completes when we click on OK, and the job completes successfully, and the status information changed for ovsvr02.example.com. The Oracle VM server now appears in the unassigned server folder. You see that it's running and was successfully. So now appears here. We reconfigure the network information of ports ETH2 and ETH3 for Oracle VM server ovsvr02.example.com before returning the server to server pool 1. For these tags, we use the Oracle VM Manager user interface. Note that when the Oracle VM server was reinstalled, it lost all of its networking and storage information except for the information for the management network. The network interfaces for ovsvr02.example.com are no longer part of the networks that have been defined in the Oracle VM environment. HV_net, storage_net, storage_net 2, and VM_net. Similarly, the storage configuration for ovsvr02.example.com must be refreshed. So in the Oracle VM Manager user interface, we may click on the Network tab, If you see the network name of unified network, remove it from the list of networks. From the networking tab, we select the herbit_net network and we click edit the selected network. In the edit network window, click the ports tab. The only port for the herbit network belongs to obsbr02.example.com. So we need to click the add new ports icon. In the add ports to network window, we expand the unassigned servers. We click the span button next to the obsbr02.example to expose the port information. And we select the checkbox for ETH2 and we may click on OK. We go back to the ports tab. We select the ETH2 on OBSR server 02 and we may click edit in the icon. In the edited ports, we select static from the addressing drop-down list. In the IP address field, we enter 192.168.2.102, and in the netmax field, we enter 255.255.255.0. We may click on OK to complete the edit operation. Note to make sure that you enter the correct IP address, or you might encounter problems later on. So you see that it's this one, 192.168.2.102. On the networking tab, we select the storage, but we may click on OK, to complete the operation. Now in the networking tab, we select the storage network and we may click on edit, selected the network icon. In the edit network window, we click the ports tab. The only port for the storage_net network belongs to obsbr01.example.com. So we may click the add new ports icon, and in the add ports to network window, if necessary, expand the unassigned servers. If necessary, click the expand button next to the obsbr02.example.com to expose the port information, and we select the checkbox for ETH3 and we may click on OK. We go back to the ports tab, so we select the ETH3 on obsbr02 and we may click edit. We may click on the edit port icon. In the edit ports window, we need to select static for the addressing. For the IP address is 192.168.3.102 and the next max is 255.255.255.0. Well, may click on complete the edit operation. And now in the edit network window, we may click on to complete the operation. So we check again that the IP address is correct, the net max and so on. So we may click on OK. Reconfigure the network information of the port ETH1 that belongs to the VM_net network for Oracle VM server obsbr02.example.com. What to do is show, we need to start a terminal. Window on your lab desktop or use an existing system. We change to root and with the SSH-L admin OVMMGR01 -P10000 we connect to the Oracle VM CLI. Password, remember, is my Oracle 1. What will is the available ports with this command. Now we use the ID for port ETH1 of obsbr02.example.com from the list of port obtainers with the list port command, The port ID is the port at the start with 0004 and is ended by B6F, is this one. Okay, the port ID on your system might be different, but port ATH0 belongs to the VM_net network. The network information for port ATH0 is as follows. IP address config type is static. The IP address is 192.168.1.102, and the IP netmax is 255.255.255.0. So now we execute this command, add port, ID equals to network, name equals VM_net. We'll wait for the output of the command. I was successful. And the next step is to execute the embedded create port ID is exactly the same. And now we need to type IP address config, IP address config type equals static, IP address equals 192.168.1.102, and IP net mask equals 255.255.255.0. We enter the command and we get success. View your work by displaying the port information for the VM_net. In the Oracle VM Manager user interface, we may click on the Networking tab. We select the VMnet, and we may click Edit in this selected network. We click the Ports tab, and now you should be able to view this entry for the ETH1 on obsvr02.example.com with the IP address, the netmax, and the addressing type to static. The networking information of the port ETH1 appears on the Ports tab. Click Cancel to exit the Edit Network Wizard. You have successfully added the Oracle VM server obsvr02.example.com to all existing networks. Note that make sure that the networking information for obsvr02.example.com is complete before continuing. The best way to verify that this information is correct is to compare with the networking information for obsvr02.example.com. This information is similar except for the last octet of the IP address. Step number 9, we refresh the storage configuration for Oracle VM server obsvr02.example.com before returning it to the pool 1 Saba pool. In the Oracle VM Manager user interface, we may click in the Storage tab. We expand the File Servers folder in the navigation pane. We select the NFS server, File Server in the navigation pane, and then we select Edit. We may click in the Admin Servers, and we verify that the obsvr02.example.com appears in the list of selected admin servers by examining the selected servers on the Admin Servers tab. We may click Cancel to exit the Edit Wizard if there are no changes. We may click in the Expand button next to the SAN servers. In the navigation pane, we highlight the iSCSI_server SAN server in the navigation pane, and we select physical disk from the perspective drop-down list in the management pane. There are warnings regarding the physical disk in the SAN server. We edit the ISCSI_server, SAN server, and click the admin servers tab. So we select this, we may click on edit, and we may click in the admin servers tab. The server obsvr02.example.com is already listed as an admin server, so we may click on cancel to exit the edit season. And with the ISCSI_server SAN server still highlighted in the navigation pane, we select the access group perspective in the management pane. Select the default access group and click the edit access group icon. On the edit access group window, click the storage initiators tab. If the initiator for each Oracle VM server is already in the select storage initiator pane, click cancel to exit. If the initiator for obsvr02.example.com is in the list of available storage initiator, move it to the selected storage initiators pane and click OK to continue. With the ISCSI_server SAN server still selected in the navigation pane, click refresh SAN server on the toolbar and click OK on the confirmation window. So we select the ISCSI server, we may click refresh, and we may click on OK. We need to add the obsvr02.example.com to server pool 1. Well, we wait for the refresh storage array process, job to finish. Okay, it was successfully executed. Now physical disk, you see that has changed from event severity critical to informational. So now in servers and VMs tab, we expose the server pool 1 in the navigation pane, and now we may click on the edit button. So we may click on the servers tab and we move obsvr02.example.com to the selected servers pane. So we select, we may click here, and we may click on OK button to complete the operation. So now the cluster information is updated. You see updating cluster, this is the information that we get for this. Well, after the job completes, we need to verify that the obsvr02.example.com can access to all the repositories. So is the next step. Well, it was successfully completed. Now obsvr02.example.com is a member of this cluster server pool. And now we go to repositories, tab, and we expand the folders in the navigation pane. We select the ISCSI_repos1 repository, and we right click and select present and present. In the present the repository to servers window, we select the servers option to change the listing from pool to servers. We select the obsvr02.example.com and click the single right arrow button to move this server to the present to servers pane. And now we may click on OK to complete the operation. We schedule the job to do so, right? We repeat the same operation for the NFL repository. So we select the NFL repository, right click, present and present. We choose servers. We choose obsvr02.example.com from available servers, and we move to present to servers, and we may click on OK. The Oracle VM server obsvr02.example.com is now completely reintegrated to the pool 1 server pool with access to all network storage and repositories, and this all for practice 5.1. Practice 5.2, perform a clean removal of one Oracle VM server and add this Oracle VM server to a new server pool. Well, in this practice, you perform a clean removal of one Oracle VM server by using the Oracle VM Manager to remove the server from the server pool. After removing the Oracle VM server, you create a new server pool and add the removed server to this new server pool. This practice demonstrates how you can move an Oracle VM server between server pools. For the tags, the first one, if necessary, migrate virtual machines from obsvr02.example.com. You cannot remove an Oracle VM server from a server pool if virtual machines are currently assigned to the Oracle VM server. So we start the Oracle VM Manager user interface, if not yet do it so. On the servers and VMs tabs, you display the list of virtual machines in your Oracle VM environment. We migrate the virtual machines assigned to obsvr02example.com to obsvr01.example.com. You can migrate each virtual machine individually, or you can use the drag and drop action to migrate the virtual machines in bulk. Note that you can also migrate the server pool level rather than migrate to obsvr01.example.com. In migrating each virtual machine individually, for each virtual machine on obsvr02.example.com, select the virtual machine and click the migrate or move icon on the toolbar. Well, in this case, you see that we have three. All right, so we could choose one, and we could choose the action for migrating. So we are going to migrate to a different server pool, or an assigned state. We may click on next. We repeat this migration process for each individual machine on obsvr02.example.com. So we choose the specified server and we may click on finish. So now the first one, it shows us that has been migrated to server one. Well, we repeat again the same step. We choose one. We may click on the migrate or move icon. We choose migrate to a VM to a different server pool, server and so on. We specify the server. This one, we may click on finish. We wait to update the server status information. Now has been migrated. And the last one, we repeat the step. Well, another option, if you drag and drop action to migrate virtual machines in bulk mode, you select the virtual machines. Imagine that we are working with these three, it's like in the previous version, right? In the previous example. And when your cursor changes to a text from an arrow, okay, you will see that that's the way that you can use to migrate from one to another. That's right. Well, I'm going to cancel the operation, but this is how it works. It's actually assign all virtual machines to obsvr01.example.com. Step number 2, you must now unpresent the OCFS type repositories from obsvr02.example.com. So we may click on the repositories tab. We right click in the SCSI underscore repos 1 and we select present and present from the shortcut menu or on the toolbar. On the present the repository to servers window, we select the options to change the resources from server pools to server. And we select the obsvr02.example.com and we click the single left arrow to move the server to the available servers pane. And we may click on OK. And we execute a job about unpresenting. Well, next step is to remove the obsvr02.example.com from the pool 1 server pool. So after the unpresent has finished, now we go to servers and VM server pools. We select in the navigation pane the select pool 1 and we may click in the edit server pool icon. We may click in the servers tab and we select the obsvr02.example.com in the right pane and use the single left arrow to move the server to the left pane. We may click on OK to complete the removal operation. We watch the job that is triggered by this operation about removing the server. At the completion of the operation, the obsvr02.example.com is now in the unassigned server folder. as you would see here in the unassigned server folder. Now it's there. So the ovasvr.example.com server retains all of its networking configuration and it access to the storage. Do you have to remember all the required steps when removing an Oracle VM server from a server pool? You get reminders for the Oracle VM Manager. If you try to remove an Oracle VM server from a server pool and this server has some virtual machines assigned to it, the job fails. If you try to remove an Oracle VM server from a server pool and an CFS2 type repository is presented to the server pool, the job fails. NFS repository does not count the removal to fail. You can also perform the removal steps from the Oracle VM CLI. To create a new server pool, in this case pool 2, on the servers and VMs tab in the Oracle VM Manager user interface, we the create server pool icon, this one. And in the create a server pool window, we enter the information as summarized in the following table. The server pool name is pool 2. The virtual machine console key map is English, United States. The VM start policy is best server. Do not select secure VM migrate. Select cluster server pool. The timeout for the cluster is 120 seconds. The storage server pool is physical disk. And the store location is filled as a result of the search physical disk. Description is optional. So when the field with the values from the table windows look like something similar to the screenshot in the activity guide, we need to make click the share button to locate the physical disk to use for this new server pool. So we may click in the select. And in the select physical window, we select the LAN with size of 12.7 GB, 13 GB, and we may click on OK. We go back to the create server pool and we may click on next. Now the server pool message window appears and finally the server pool is created. In the add servers window, we select ovsvr02.example.com and move it to the section, to the selection panel. We select, right. And finally we may click on finish to complete the configuration of the new server pool. This action adds ovsvr02.example.com to a new server pool. When the operation completes, you have two server pools, each with a single Oracle VM server. And that's all for practice 5-2. Practice 5-3, perform a migration for the NFS-based virtual machine between the two server pools. In this practice, you migrate an NFS-based virtual machine between server pools. It demonstrates how this cross-server pool operation is possible when both the Oracle VM servers involved in the migration operation have access to the repository where the resources for the NFS-based virtual machine reside. For the task, the first one, we migrate the running virtual machine NFS_PVM1 from pool 1 server pool to pool 2 server pool. From the servers and VMs tab, well, first of all, we get logged, if not yet already done, as admin my Oracle VM. And from the servers and VMs tabs, we display the list of virtual machines assigned to ovsvr01.example.com. So we expand server pools, pool 1, we highlight the ovsvr01.example.com, and in the perspective drop-down list, we choose virtual machines. Well, in the virtual machines other than NFS_PVM1 are running, stop them at this time. In case you see all of them are stopped. For example, to stop X86_PVM1, select in the list the virtual machines for ovsvr01.example.com and click the stop icon. Click OK in the confirm window, until X86_PVM1 has stopped. To proceed, we are going to start now the NFS_PVM1 virtual machine. So we highlight the NFS_PVM virtual machine and we may click on the start button. Well, next step, we wait to check that was successfully executed. Now it's running. The next step is to click the repository tab to verify that the NFS repository, repositories, NFS underscore repo is still present to the obsvr02.example.com Oracle VM server. In the navigation pane, we select the NFS underscore repos with pan repositories, and we select the NFS underscore repos. In the management pane, we select the info perspective info, and we scroll down if necessary to expose the section listing the Oracle VM servers to which the repository is present. So we check that present two servers, both of them, obsvr01 and obsvr02. If obsvr02.example.com is not in the listing, we need to select the NFS underscore repos. In the navigation pane, we click the present and present select repository in the navigation pane, and in the present to this repository to servers, we move obsvr02.example.com to the present to servers pane and click OK to trigger the operation. Click the servers and VMs tab to return to the listing of virtual machines. Note that you can display virtual machines for a particular Oracle VM server or server pool. You cannot get a listing for all virtual machines across all server pools. You therefore have to move from one server pool to another to track the movement of a virtual machine that is being migrated across server pool. Make sure that the NFS underscore PVM virtual machine is running. You will see here we highlight the NFS underscore PVM, so now it's running. And we may click in the servers and VMs tab to display the list of virtual machines assigned to obsvr01.example.com. We select the NFS underscore PVM1 from the list of virtual machines and click the migrate or move icon. We have this icon and we may click down there. In the migrate or move virtual machine NFS underscore PVM window, you are present with two options: migrate a running VM to a different server pool with a same server pool, or migrate a running VM and migrate its local storage to a different server with the same server pool. There is no option to migrate a running VM to a different server pool. You cannot live migrate a virtual machine across server pool, even if all of the resources for a virtual machine reside in repositories that are present to the source and target VM server selected for the migration operation. We may click on cancel to exit the window. We have stopped the NFS underscore PVM1 virtual machine and migrate it from pool 1 server pool to pool 2 server pool. We select the NFS underscore PVM virtual machine and click the stop icon. This is the stop icon. When we click there, we may click on OK in the confirmation window. When the NFS underscore PVM virtual machine is stopped, select it from the list of virtual machines and click the migrate or move icon. Notice that your available choices are different when migrating a stopped virtual machine. So we repeat again, migrate or move. You can migrate this virtual machine to migrate a VM to a different server pool or an assigned state, or move this VM to a different repository. Choose migrate a VM to a different server pool, or an assigned state as the action to perform. This is the default. Click next to continue. On the next screen, you select target for the migration. You can migrate this virtual machine to an assigned virtual machines folder, a specified Oracle VM server in the server pool itself by removing it from its current server, a different server pool. You can read a description of these options by clicking the help option. We select the server pool option and select pool 2 from the drop-down list. Server pool option, pool 2 from the drop-down list. We may click on finish to trigger the migration operation. The NFS underscore PVM1 virtual machine disappears from the list of virtual machines for the pool 1 server pool. You check that the NFS have disappeared. Now we select the pool 2 in the navigation pane to expose the virtual machines that are present in the server pool. We expand server pool 2. We highlight obsvr02.example.com OVM server. and we checked in this case for virtual machines. That is this one, is the NFS underscore PBM1. The NFS underscore PBM1 is the only virtual machine present in the pool, and the virtual machine does not have a server assignment. Well, the way that we verify this in pool 2 virtual machines, but you see that the server has no virtual machines assigned yet. Next, step 3, we move NFS underscore PBM1 to obsvr02.example.com and start it. Note that you do not have to move the NFS underscore PBM1 to an Oracle VM server before you can start it. If you start a virtual machine that is not currently assigned to a particular Oracle VM server in the server pool, the virtual machine is started on a server based on the server's pool VM start policy. Choose one of the following 2 techniques to move the NFS underscore PBM1 to obsvr02.example.com. Highlight the NFS underscore PBM1 and select the migrate or move icon. Choose migrate VM to a different server pool or an assigned state as the action to perform, and click next to continue. Select obsvr02.example.com as the target Oracle VM server for this operation. So we choose specify server, choose the, and click finish to trigger the migration operation. Or another option is to drag the NFS underscore PBM from the management pane to obsvr02.example.com in the navigation pane. Well, another option is to choose the VM and to migrate or to drag and drop into the pool or into the server. Note that the entry in the server column in the management pane changed from blank to obsvr02.example.com. Now has changed from blank to this server. Start the NFS underscore PBM virtual machine to ensure that it can start properly in this new location. So when we click on the start, and we need to check the status that is running. We schedule the job. Now it's running and the status changed to running. And that's all for practice 5.3. Practice 5.4, create a new ISCSI repository for the pool 1 server pool. This practice, you create a new OCFS2 type repository for the pool 1 server pool. For this repository, you need an unused LAN in the ISCSI underscore server SAN server. You use this new repository in the next practice to show dependencies between repositories when trying to delete or release a repository. For the first task, we locate the LAN that you plan to use for creating the new repository. So we may click on Storage tab, and we select the ISCSI underscore server in the navigation pane and display its physical disk by selecting the physical disk perspective in the management pane. But we expand the SAN servers, we select the ISCSI server, and in the perspective drop-down list, we select physical disk. You use the LAN named LIO-ORG5 between parentheses for this practice. You must use a LAN that is at least 12 gigabits in size to create a repository on the LAN. So it's this one. We create a repository for the pool 1 server pool. So we may click on the repositories tab in the navigation pane, click the create new repository icon on the toolbar. Fill the repository information window by using the information in the following table. The repository name is ISCSI underscore repos2. Select the type as repository location physical disk. In the server pool, this field appears when the physical disk option is selected. We choose pool 1, a physical disk using the search button on the LAN name LIO_ORG 5 between parentheses, And in the description, we type this repository is created on the LAN name lao-org 5 between parentheses. After filling the information, click the search icon to locate the LAN for this repository. And we select the physical disk, show you before. And we may click on OK to return, and now we may click Next to create the repository. So the repository is being created. The job takes about 12 to 40 minutes to complete. But optionally, while the repository is being created, we have the option to log in to obsvr01.example.com and find the process that creates the repository. So we minimize all the windows. We open a new terminal with Ctrl+Shift+. We increase the size of the font. We open a terminal in the lab machine, so we change to the root user, and we connect with SSH to obsvr01. And the password is Oracle for the root user in this server. We use the ps command pipe to the grep command to find and display the mkfs.othfs2 process running on obsvr01.example.com. With Ctrl+O, we clean the screen, and ps -eaf pipe grep mkfs. Well, you get this output, and now we use the exit command to terminate your SSH session to obsvr01.example.com. Well, creating an OTFS base OTFS2 base repository involves creating an OTFS2 file system on the repository LAN. The make file system.otfs2 command creates the file system on dep mapper and the ID for the device, which is named LIO-org and between parentheses 5 in the Oracle VM Manager database. After the repository is created, the present to server windows appears. So we return to the Mozilla Firefox and we wait for this window. In the present to servers window, move obsvr01.example.com to the selection pane and click Finish. Select obsvr01.example.com. We make press in the right arrow and we may click on Finish. Your new repository called ISCSI_repos2 appears in the list of repositories. Well, we check in the repositories tab. In the navigation pane for the repositories appears the ISCSI_repos2. And that's all for practice 5.4. Practice 5.5, create dependencies between the two repositories for the pool 1 subpool and release ownership of one of the repositories. In this practice, you perform the following tasks. You create a small virtual disk in ISCSI_repos2, the new repository. We add this virtual disk to the ISCSI_PVM2 virtual machine, thereby creating a dependency of resources for the ISCSI_PVM2 virtual machine. The ISCSI_PVM2 virtual machine has resources, the vm.cfg and the ISCSI_PVM1 disk in the ISCSI_repos1 repository and a small virtual disk in the ISCSI_repos2 repository. We attempt to release the ownership for the ISCSI_repos1. When the job fails, you fix the problem and try it again. When the ISCSI_repos1 repository is released from pool 1, you take ownership of the repository for pool 2, and you start a virtual machine in ISCSI_repos1 to make sure that the virtual machines are intact after the move of the repository from pool 1 to pool 2. Assumptions at this point: there must be no running virtual machines from the ISCSI underscore repos1 repository. The virtual machine in the NFS underscore repository is running. Well, we could check this with the service. The NFS underscore PVM is running, but remember this is in the NFS underscore repos repository. And for all the other ISCSI virtual machines, you see that all of them are stopped. But for the tags, first of all, we create a 4 GB virtual disk in the ISCSI underscore repos2 repository. So when we click in the repositories tab, in the navigation pane, we expand repositories and we expand the folder under the ISCSI repos2. We select the virtual disk in the navigation pane and click the create virtual disk icon in the management pane. In the create the virtual disk window, we enter the ISCSI underscore repos2 underscore vdisk underscore 4GB for the virtual disk name, and we enter 4 for the disk size in gigabits. Accept the default allocation type and may click OK to create the disk. The new disk appears in the management pane. So it's here, right? Next step 2, we add the new virtual disk to the ISCSI underscore PVM2 virtual machine. So we may click on the servers and VMs tab. We display the virtual machines for the pool 1 perspective drop-down list virtual machines. We select the ISCSI underscore PVM2 virtual machine in the management pane and click the edit icon. We put a focus on this and we may click in the edit icon. From the main edit virtual machine window, click the disks tab. For the slot 1, select virtual disk from the disk type drop-down list. May click the search icon in the actions column for the slot 1 and select the ISCSI underscore repos2 underscore vdisk underscore 4GB from the list and click OK. And now click OK on the disk tab to complete the edit operation. Attempt to release the ownership for repository ISCSI underscore repos1. Releasing ownership does not destroy the resources in the repository. It removes the cluster identification for the OCFS2 type repository and the Oracle VM manager ownership. The repository can be reclaimed by another subpool or a different Oracle VM environment. We may click in the repositories tab. We select the ISCSI underscore repos1 repository in the navigation pane, and we may click edit, select repository icon on the toolbar. On the repository tab, select the release ownership checkbox and may click on OK. Well, we'll schedule a job. The job to present the repository from obsvr01.example.com succeeds, but the job to release the repository fails. You get a failure. Click the details button for the failed job to examine the job information. You have here the details button. Note, if necessary, use the scroll bar in the job summary pane to display the details column. Well, here you get the error. The ISCSI underscore PVM2 virtual machine has a resource signed in the other repository, ISCSI underscore repos2, and this dependency blocks the operation to release the ownership of the repository. Click close to close the window. Remove the dependency between the repositories by removing the ISCSI underscore repos2 underscore vdisk underscore 4GB virtual disk from the ISCSI underscore PV2 virtual machine. So we select the ISCSI underscore repos1 repository and click the present and present repository icon to present the repository to Oracle VM server OVS vr01.example.com. You may click here. Note that you must have at least one Oracle VM server with access to the repository to manipulate the contents of the repository. We select the servers option and we move the OVS vr01.example.com to the RAID pane and click OK to present the repository to this Oracle VM server. Okay, after that we may click in Servers and VMs tab. We select the ISCSI underscore PVM2 virtual machine and click the edit icon. On the disks tab, select the empty from the disk drop-down list for the disk slot 1 and may click on OK to complete the edit operation. Now try to release the ownership of the ISCSI underscore repos1 repository again. So we may click in Repositories tab, we select the ISCSI underscore repos1 and we may click Edit, select repository icon, and on the repository tab of the Edit repository window we select the Release Ownership checkbox. Note that when you select the Release Ownership box, the server pool field is disabled automatically. We may click on OK to complete the operation, and the operation completes and the repository is no longer visible in the navigation pane. Now you have the job running. And now it's going to be finished successfully. All right. We select the Show All Repositories option in the navigation pane. This one. And we click the expand button next to the repositories to display the list of repositories. The just release repository appears in the list of repositories, but it is now an ownership and owned. As such, it can be reclaimed by any other server pool with access to the LAN on which the repository has been created. And that's all for practice 5.5. Practice 5.6, reclaim ownership of the newly released repository for Pool 2. In this practice, you reclaim ownership of the now unowned ISCSI underscore repos1 repository for Pool 2. At the conclusion of this practice, you have successfully moved an OCFS2 type repository from one server pool to another. For the task, first step, reclaim ownership of the ISCSI underscore repos1 repository for the Pool 2 server pool. We may click on Repositories. We select the ISCSI underscore repos1 and click the Edit Select Repository icon in the toolbar. And we select the Take Ownership checkbox. The server pool drop-down list is enabled. So we need to select Pool 2 from the server pool drop-down list and click OK to complete the Take Ownership operation. As part of the Take Ownership operation, the repository is automatically present to the single Oracle VM server in the Pool 2 server pool. You would check that now it's owned by you. What happened to the virtual machines in the ISCSI underscore repos1 repository that were assigned to the Pool 1 server pool? Well, we try to check this. And we go here. Now for the pool, you will see that there's no virtual machines, right? Well, locate the virtual machines that are in the ISCSI_ repos 1. Select the SEBA pool 2 in the navigation pane, and all the virtual machines with resources in ISCSI_ repos 1 appear in the list of virtual machines. The virtual machines with virtual resources in the ISCSI_ repos 1 repository are now assigned to pool 2, but not to obsvr02.example.com, the only OVM server in pool 2. You can manually migrate a virtual machine to obsvr02.example.com to start it. Alternatively, you can drag and drop all the virtual machines to obsvr02.example.com in the navigation pane. Note, recall that the resources for the NFS_PVM virtual machine reside in the NFS_ repository, and that this virtual machine was migrated to obsvr02.example.com, which belongs to pool 2. So, in conclusion, you can successfully move repositories between SEBA pools, but beware of dependencies between repositories may prevent you from successfully releasing the ownership of a repository. Clean up, log out from your Oracle VM Manager user interface season. We may click on the logout, and we terminate all the seasons to obmgr01.example.com. We could close all the windows. And that's all for practice 5.6.